lesson, which is 2-1 in your textbook on writing expressions. We've started this in class just a little bit, but I wanted to go and do a video lesson for you to point out some important details that we're going to be talking about in class for this unit. Our learning goal for tonight is I will write numerical expressions with variables to represent relations expressed verbally. That sounds like a huge mouthful of words that are kind of jumbly, but we are going to go through that in class, and I will make sure that we understand what all that means. Right now, I want you just to know that expressions are not the same things as an equation. We're not going to be solving anything right now. In an equation, we do solve because that sounds like equal, so think equation and equal. We're just writing expressions, okay? And an expression is going to have a variable, some type of an operation of add, subtract, multiply, or divide, and a number. So our vocabulary, our first one is variable, which is a quantity that can change or vary and is often represented with a letter. So if you see the word vary and think variable, we might say something like the weather in Missouri varies often, which is very true. We have 4 seasons. It's very cold, it's very hot, it's nice in the spring, and it's chilly in fall, and so it varies, it changes. So when we see the word variable, we can have a G, we can have an S, but those can stand for any number whatsoever. So we'll see that as we go on. The second word is coefficient. That is a number that is multiplied by a variable. So that the word coefficient is just specific to numbers that are multiplied by a variable. An algebraic expression is a mathematical phrase that has at least one variable and one operation. So again, it's going to have a number, some type of variable, which is going to be a lowercase letter. You're not going to see these as uppercase. It's going to be a lowercase letter, and one operation or more. So adding, subtracting, multiplying, dividing, or there could possibly be 2. So go ahead and pause and write that down in your journal, and then we will move on. All right, some operation words. We talked about these in class and did that activity, and I want to make sure that we can't think of any more. Now that we've already talked to them, there may be more that we could add to our list. So to write expressions, we have got to be familiar with some of the vocabulary that stands for the different operations, because when we are asked to write an expression, they're not going to go easy on us and use words usually like add, subtract, multiply, and divide. They're going to use expressions, and we're going to need to be able to translate those into what operation that we need. So if you look, I made 4 columns of add, subtract, multiply, and divide. And I wrote some phrases and some words down that come to my mind when I'm adding, subtracting, multiplying, and dividing. And I want you to read through those and add to that list if you think that you can think of anything else that I have left off. I didn't put all of them on there because that would take me a while, but I put some of the main ones that we'll see. So for adding, I have some, I have more than, altogether, in addition to. For subtract, I have difference, minus, less than, and decreased by. Multiply, I have times, twice the product, and doubled, which we could add tripled. Divide, I have quotient, divided by, half, or split among. All of those should make you think of the 4 operations. So if you want to go ahead and stop and pause and add to that list any that you can think of, and then we can talk about those in class. So steps to writing expressions. The first one is we need to identify what operation that this expression includes. And notice that I put the S's in, we could have more than one. So sometimes it may be that they're asking us to add and multiply or subtract and multiply. So we have to listen very carefully because there may be more than one. Secondly, think about the order that the variable and the number must be in to end up with a logical expression. Do not use the multiplication symbol X. We talked about this in class because this looks like a very common variable. So if you use the multiplication symbol and you use the variable X, this could just look like XX, and we don't want that. So we're going to teach you how to show multiplication without that multiplication symbol. Fourth, instead, show a number being multiplied by a variable by placing it directly next to parentheses or a number. So for example, if I wanted to say 7 multiplied by y, notice that I don't have a multiplication symbol. It would look like 7xy if I did. I simply take the 7 and I take the variable y and I smash them together is what I call it. And notice that y is lowercase and that you will always see that the variable will always go behind the number. The variable will never go in front. So I have 7y smashed up together and that means multiply. And if you see a number that is smashed up right next to parentheses, that also means multiply. So in this case, I am multiplying 2 by the difference of x and 3. So notice I put x minus 3 in parentheses because order of operations tells me I need to do that first, and that expression obviously told me that I needed to multiply 2 by that whole difference. So I needed to offset that with parentheses. So number 5, I want you to think about this, that a number directly shoved against a set of parentheses means multiply. So we've got to get that in our head because algebraically we're going to be seeing that a lot. And number 6 is say the expression out loud and write what you are hearing. And I know that may sound silly, but I want you to say the expression out loud and then look to see what you've written and is what you have written down exactly what you are reading or what you are hearing. And ask yourself again, as I've always told you, does this sound logical? So keep asking yourself that. So stop and write down those 6 steps, and then I'm going to give you one to look at, and then we're going to try some on your own. Okay, here's an example. I'm going to write this sentence expression. So first we're going to see a sentence that has words, and our job is to take that and turn it into a numerical expression, numerical meaning number. So 5 less than the letter y. So if I look, I see my 5 parts here. I have 5 as my number, less than is my operation, it shows me subtraction, and y is my variable. So now I have to figure out what comes first. So I have 5 less than the letter y. So I'm using subtraction. And please notice, and we will really push this in class, that when we are subtracting, order always matters. For example, 5 minus 3 is not the same as 3 minus 5. Now, when we talk about adding, I could tell you that 5 plus 2 is 2 plus 5, and then order doesn't matter quite as much, does it? But in subtraction, order matters most importantly, actually. So we got to make sure that when we see these subtraction ones that we're putting the variable and the number in the right place. So we need to know what goes first. So the answer is y minus 5. And can you see why the 5 is last? And I want you to pause and write your answer. Why is the 5 last? Okay, when we go back and we look at 5 less than the letter y, in order to take 5 from something, does it make sense to you that we need to have something to begin with? If I said I need $5 from you, I'm going to take $5 from you. Doesn't that imply that you already have some money? So I'm taking some from you. So in this case, you have to have y in order for me to take 5 from it. So 5 less than the letter y says that I have y, and then I'm taking 5 from it. So now y has 5 less than it did. So y minus 5 is the correct answer, and 5 minus y is not. All right, I want you to copy down these 4 questions, and you are going to turn these statements into numerical expressions, and then we're going to check our work. We have number 1, 12 times a number g. We have the difference of a number m and 18. We have a number r increased by 20, and 22 divided by a number s. So go ahead and stop and write those down. And then I'm going to show you my last slide, which is a challenge problem. And we're going to end by giving you the answer to that one. I'm going to work all 5 of these out. So I'm going to do these 4 that are not quite as difficult. And then we have our challenge one. is 9 times the difference of y and 5. So think about maybe why that is a challenge problem. So I'm going to read it again. 9 times the difference of y and 5. So go ahead and stop. Start working on those, and then we'll do those together and we'll see how you did. Simply is this. I have 12